When we think of fabric, we usually picture something like a cotton shirt, right? Something woven or knit. But what if I told you that some of the most common, most essential materials in our lives are made in a completely different and honestly, a much more revolutionary way?
Okay, think about this for a second. A surgical mask, one of those reusable bags you take for groceries, and a simple wet wipe. They seem totally different, don't they? But they all share a hidden connection, a secret manufacturing process that has totally changed the world of textiles.
And here's the answer. The one thing they have in common is that none of them are actually woven or knit. They all belong to this special family of fabrics that just skips those traditional steps entirely. It's a material that is literally all around us, but one we hardly ever stop to think about. So that begs the question, right? How in the world do you make fabric without weaving? Well, let's pull back the curtain and take a look at the incredible technology behind what we call non-woven fabrics. So here's the deal. At its core, a non-woven fabric is made directly from loose fibers. You can just forget about spinning yarn. Instead, you take these raw fibers and you bond them all together using heat or chemicals or even just pressure. It's a much more direct, modern, and incredibly efficient way to get the job done. And Miss Chart really breaks it down. Look at the traditional process. It's got multiple steps. You take the fibers, you spin them into yarn, and then you weave or knit them. Non-wovens, on the other hand, they basically cut out the middleman. You go straight from loose fibers to a sheet-like web, which is then bonded to create the final fabric. So what's the recipe for making these things? It's actually surprisingly simple. It really just boils down to three main stages. So it all starts with creating a sheet of fibers, which we call a web. Then you've got to lock all those fibers together. That's the bonding part. And finally, you add any special finishing touches you need. Let's break down each one of those stages. All right, so step one, creating the web. You can think of this as building the entire foundation for the fabric. This fiber web is basically just a fluffy mat of fibers. A good way to picture it is like a delicate cloud of cotton candy before it gets all pressed and solidified. At this point, it has no strength at all, but it is the blueprint for the final product. Now, there are a few pretty clever ways to form this web. You can use something called carding, which is kind of like combing all the fibers into a nice uniform sheet. Or there's air laying, which uses jets of air to spray the fibers onto a moving belt. And wet laying is a lot like making paper, actually, where you suspend the fibers in water and then lay them out to dry. Now for step two, bonding. And this is the crucial step. This is where that flimsy web gets all of its strength and transforms from just a loose pile of fibers into a durable, usable fabric. I mean, without the bonding step, the web would just fall apart. This is what turns that delicate sheet into a material you can actually do something with. This is where the magic happens. So, how do they do it? Well, there are three main ways. Mechanical bonding uses thousands of tiny needles to physically punch and tangle the fibers together, just like when you make felt for a craft project. Then there's chemical bonding, which uses a binder, basically a special glue, to hold it all together, kind of like paper mache. And finally, there's thermal bonding, which uses heat to melt plastic-based fibers just enough so they fuse together wherever they touch. And the method they choose has a huge impact on the final product. Remember that reusable shopping bag from the beginning? That thick, almost felt-like texture? That is a classic sign of mechanical needle punching, where all the fibers are physically tangled up to make a really strong, dense fabric. And the last step is finishing. This is where the fabric gets its special powers. Special treatments can be applied to make it softer for, say, a face wipe, or more absorbent for a diaper, or even water-resistant for things like medical gowns. It's really the customization stage. So, we've seen how it's made, but why is this modern method so important? why has it become so incredibly common in our daily lives? What's the big deal?
Well, the advantages are huge because you're skipping that whole weaving step. Production is unbelievably fast and way more cost effective. But the real game changer is just how versatile it is. You can literally engineer these fabrics for very specific jobs, making them super absorbent, incredibly strong, soft, or even capable of filtering microscopic particles. It's a truly tailor-made material.
Let's go back to that surgical mask. It uses a really special process called melt blown, where molten plastic is blown through these teeny tiny nozzles to create an incredibly fine web of microfibers. It's that dense, complex structure that lets it filter out airborne particles while, still being breathable. Pretty amazing.
And the applications are just everywhere. In hospitals, with masks and gowns, in our homes as diapers and wipes, inside our cars as filters, and even under our roads as something called geotextiles. They are truly the invisible workhorses of our modern world. So here's the crucial takeaway. Non-woven fabric isn't just some novelty. It's an essential, high-tech material. It's been engineered to perform very specific tasks and to do them efficiently and affordably, making modern life possible in countless ways we don't even see. So the next time you pick up one of these items, you'll know this secret behind it. And it makes you wonder, right? With its endless potential for customization, what new challenges will this remarkable fabric help us solve tomorrow?